bit and then so yesterday I introduced the sine law. We started with sine law. We're going to go cosine law as well. So the first part, if you go back to 260, I believe, or actually 261. On 261, you had an example of how we use the sine law, making sure we have a pair. That's always key to sine law. Everything is in pairs, right? So if you have known pair, then that's your setup. And then you just set up the proportion with the other angle on the side across from it. We cross multiply and divide to figure out the side. And we did that for the rest of that triangle. Then, towards the end, that was more towards the end, I walked through an example where we're solving for angles, right? And so the initial step is exactly the same, right? You have your pair, but on the other side, you have the side length across from the angle you're interested in, right? If you see that, sometimes you don't have another choice but to figure that out first, right? Because you have that side and you want to know the angle across from it, and here it is. It's almost like the other pair where one of them is unknown. We cross multiply and divide there as well to get us, right, a decimal, and it always has to start with 0. If you do this and you get anything other than 0 at the beginning, you did something wrong. You'll get an error. It's not going to work, okay? So what we did is to figure out that angle. Sine shows up. Yeah, let's go back to our notes here. And sine, it's almost like it shows up on the other side of the equal sign, but it's now the inverse. And I told you that, right, on your calculator, you most likely have to press shift or second function or something like that. And when you press sine, it's actually going to access the inverse, which is just above it in yellow or red, whatever your calculator has. So you need to figure the inverse. We use at least 5 decimals. And so there we figure out our angle A. And once we have that second angle, we can find the third angle by just knowing that the sum of angles in a triangle is always 180. So we take 180 minus the 2 angles that are known, and there's our third angle. Okay, let's try this now. So I will do one more with you, and you'll do the other 2 where we're going to start mixing it up. So go to 264. And so I want you to, at the very least, be able to get started. If you get something wrong after, we can work with that, but you need to be able to get started. And you look at this triangle, and you should see that there's an angle and the side across from it, you have that pair. You should immediately identify that you have to use the sine law. We only know the sine law right now, so obviously it's going to be sine law. But down the road, it's not going to be so obvious. So take that pair, set it up. So sine of 121 degrees, right, over the side length across from it, 77.5 meters. Okay, that is equal to, even though, guys, listen carefully. Let's say this question would have asked you to find C right off the bat. Like, that's the first thing it's asking. You cannot do so at this point because you don't have the side length across from it, but you do have the side length that's across from A, which happens to be the one they want you to find. Okay, so you don't have a choice but to do that anyways. So you just set it up like that. Sides match up with sides, angles with angles. So then you cross multiply and divide. And please do not just add another equal sign to this thing. Don't do this. Yeah, and then keep going side. Don't do that because you're going to lose marks. Okay, underneath it, you keep sine A together. Sine and an angle is glued together every single time. You don't just get rid of it. So this is 45.1 times sine of 121 degrees divided by 77.5. Okay. Let me zoom into that a little bit because I'm going to stick to that side for now. You're not squinting. And here's where you have a choice here what you want to do. I basically say multiply these to hit equals, then divide. So you can put equals next to it. It's okay here. And then you're going to go 0 point and figure out what the rest is. So let's go ahead and do that, please. You do it with your calculator. I want to make sure that we all know what we're doing. If your calculator opens brackets at all, close them after. So I typed that in, right? Oops. I go equals and then I go divide by 77.5. We should all get, if you have it set to degrees, you should get 4,988. And I told you to use 5 decimals if you're going to stop, right? So 1, 2, 3, 4, 5. You would stop right there. The 6 bumps that to a 2. I use all decimals. Watch my calculator. Before I do anything, though, I'm going to say that angle A, it's now, right? You go sine inverse of this thing that you just found. And I allow you to just go like this at that point because you already wrote it down once. Just do that. Save some time. And look at my screen here. I keep this on there and I just go shift, press sine, and then I hit equal. It will, my calculator automatically takes that answer and just uses everything to find the inverse. It's like sine inverse of the answer that you got. That's 2992. That's how you find an angle. The inverse is must. If you're finding angle, you're using the inverse. Let's go ahead and do more than that. Let's find angle C. I'm going to zoom out a little bit. Right up here. Angle C, this one right here, is going to be found by taking 180 minus the 121 that we already know and minus the 2992. I know some of your teachers in previous grades rounded angles to a whole number. We keep them to decimals. Okay, that's the province saying that, right? They want us to do it that way. And so we go 180 minus 121 minus 2992. So we're going to say that that's 29.08 degrees. I'm going to box that in because it does answer the question of what is angle C now. So you could do this again, but I wouldn't recommend that. Like once you have 2 angles, just take it away from 180 and you're done. What about side C, this one here? I'm going to use a red pen here and just say that this is side C, right? Because it's across angle C. So I'm turning this into a mixed question, okay? Watch carefully. I'm using this pair that I already have. And I set it up again, just like I did before. I set that up again because this is a fact, right? And now I'm going to use this angle here, which is the measure of that angle. So I'm going to go sine of 29.08 degrees over side C, okay? So this angle is across this side, right? And then you cross multiply this way and you divide that way, right? So cross multiply and divide. So C is 77.5 times, these are multiplying, and then I divide it by sine of 121. And I'm going to come and see you if you have calculator issues. Don't worry about it too much. I can help you with that. I can help you with that for sure. So I'm going to type that in, 77.5 times sine of 29.08 equals, then I'm going to hit divide sine of 121 equals, and I get that side C is 43.94. We are in meters. Lowercase is side length. Uppercase is our, and if you're, what I do is I use that angle symbol to make sure that people, right, in the degree, you should tell that this is an angle and this is a side length because it's in meters, right? So we've basically solved this triangle like that. Now, I want you to try B and C. Do the same thing I just did. Solve for everything that's missing. So in this case, angle H is missing, angle G is missing, and side G. You can go lowercase g right here. You can only solve for one thing at a time, but guys, you can't do more than that, right? So go and work through that. I will walk around after I do my attendance. Here are the answers to the rest. I never thought of it that way before, but you might not have to worry about finding side M and just stop there. They might not worry about either one of these, so you just stop there, right? So either see it as just a shorter question. This is if it's asking for angle M, and this would be if it's asking for side M, which is really you solving the triangle, right? You need 3 things to get started. There are still 3 things to figure out, right? Because a triangle has 3 angles, 3 sides. Okay. All right. I'm gonna switch it up a little bit. So follow me. Let's go to 265. So again, I guess this is a good time to mention. Some students ask, are you gonna start asking us from previous units? Nikolai Solomon, just for 1 second, okay? Are you gonna start asking us for stuff that we learned in vehicle finance on some ACs? And the answer is yes. From time to time, I'm gonna throw in a use private in there, or a depreciation, or leasing. So your blue study sheet that you've made, bring it with you, because I'll tell you today you're going to need that one as well. But as we're doing this one, just have a piece of loose leaf right now, just a scrap piece of paper, and just bring that with you. Just can't, I don't want you to, like some students just take out their booklets, like I'm just going to use this page, Mr. Dirks, and like that doesn't count, okay? You have to have your handwritten piece of loose leaf that is your study sheet, quote unquote, right? And so make sure you bring the blue one with you. Bring the vehicle finance booklet with you as well. It doesn't weigh that much, right? I'm not making you carry like heavy textbooks or anything like that. So just be aware of that. All right, let's look at this question here. If you have a ruler, that would be great. If not, I want to introduce hidden dimensions into a triangle from now on. So I'm gonna make a dashed line like this. Like it's actually a 90 degree, make a 90 degree box like that. And you're like, what about the 85 there, Mr. Dirksen? What's up with that? Yeah, that's a bit of a problem. So we're gonna make sure that this angle right here, that angle right there is 85 degrees. That's what they're trying to say. The angle formed between the tree and the ground, that is 85 degrees. And if you read the question, I'm just gonna have this up here. It does. Do you notice that it gives you a diagram, but sometimes students are like, I don't get it, right? Just look at the diagram, and it usually trumps what it says on the actual word problem. But the tree is leaning at an 85 degree angle with the ground. That is very important to highlight, right? So this tree makes an 85 degree angle with the ground. Miguel is 30 meters from the base of the tree, right? So we can clearly tell that 30 meters is from end to end. The angle of elevation, you should remember that I talked about that yesterday. To the top of the tree is 32 degrees. This is, right? This angle is the angle of elevation right here. And remember, for angle of elevation and depression, what's always there? The horizontal line, right? And think about it, the ground acts as your horizontal line, so that is the angle of elevation. So I'm reviewing a few things. So this is asking for the length of the tree. Instead of m, I'm going to call this lowercase l. Okay, so the length of the tree, it's kind of tilted, but the length of the tree we're going to call l. Okay, so let's start solving this. Do we have a pair? Can we get a pair? We have two angles, right? So this is a hidden pair example. So write that down. Because down the road, if you don't have a pair, if you cannot come up with a pair, it's not sine law, right? So this is a hidden pair. This couple hasn't announced it yet. They're not official, right? It's a hidden pair, okay? So angle T, which is this angle up top here, right, is going to be found by going 180 minus 32 minus 85. Angle T, if you do this, you get 63 degrees. I'm just going to underline it because it's important. It doesn't answer the question, but it most likely would be worth a full mark. And I will use a pen and just indicate that that whole angle is 63 degrees. Okay? And you now effectively have created what we call a pair. Okay? So the only way to get started with this is sine law. Okay, so let's go ahead and do this. So I'm going to start with my pair. Sine of 63 over 30 meters is equal to, which angle do I have to use up here? Because I want to figure out L. Which angle is across from it? It's 32 degrees, all right? So the 85 is not being used here. So you got to go sine. Remember that, it's not just 32 degrees. It's sine of 32 degrees. Okay. And you cross multiply and divide. Okay, so you go 30 times sine of 32 divided by sine of 63. So when you do that, you get 17.84 meters. This is the length of the tree. Okay. You could have called it X, Y, whatever you want to call it. I chose to go with L, right, for length. So that's the length of the tree. But now we want the actual height of the tree. Okay? Even though a tree is slanted, you would measure straight from the ground to the top, right? So if you go back up to this triangle here, I introduced that dashed line. That's what we call H. So put H right next to that dashed line there. It splits, that line splits this triangle into two triangles. Okay, so that's the key here to answer the next one, which says calculate the height H, right, of the tree. And let's copy that for 1 second. I'm going to exaggerate that triangle. I'm going to make it a bit more obvious. So let's make it look like this. This is length, which is, we just found, is 17.84. This is our dashed line, which represents the height, which is always, height is always measured at a 90-degree angle. This angle right here is 85 degrees. Why is it 85? I'm copying it from up top here, right? So that 85 comes here. And that's 30 from end to end, right? 30 from end to end. I know this is 32 degrees here. And I know that the top is 63 here, but I'm going to omit that for now. And what you can do is you can pick one of these guys. You have to, because you're interested in that dashed line that is cutting that triangle, you pick one of these two right triangles. I'm going to pick this side because it has more information. So this is triangle number 2. So let's draw that out here. Just copy for now. This will help you later. We know this is 85 here. We know that this is 17.84 meters. And this is height. And if you remember, I told you that sine law also works with right triangles. Do you remember that? Yeah, you were sleeping. You were sleeping. You weren't paying attention. No, I'm just kidding. You were. So this is a pair. You've now cut out that right triangle. And this is a pair. What does this represent? A 90-degree angle, right? So sine of 90 over 17.84 is equal to, I want to figure out side H. And I happen to have the angle that's across from it, which is 85. And you cross multiply and divide. 17.84 times sine of 85 divided by sine of 90. And this will give us the height of that. This is going to come up again, okay, this scale. And so watch this. If I go 1784 times sine of 85, look on my screen just for 1 second. If I hit equals right now, I get this. If I go divided by sine of 90, watch what's going to happen to that answer. Nothing. Right? Let's write that down and then I'll explain why. 17.77 meters is the height of that tree. The length of the tree. So if you're a squirrel, you would care about the length of the tree, right? Because you have to like run along the tree to get to the top. But if you want to know how tall, like how high off the ground it is, then this is what you're after. Everybody press sine of 90, or some of you need to press 90 sine. You get 1, right? So that's why when we divide by sine of 90, nothing happens, because you're dividing by 1. Okay, let me recap one more time, okay? Pay close attention, because it's going to help you with the example I'm going to give you in a bit. At first, I did not care about that dashed line. I kind of just looked at the triangle, the big triangle there. But then later I zoomed in, and that's most likely how it's going to be. And you're going to have to pick one of those right triangles that is created by that line that cuts it. Sometimes it doesn't matter which one you pick, because you have the same amount of information on both sides. But sometimes it matters which one you pick. In this case, there was more information on this side. I had this figured out already, so that's why I picked that side of the cut triangle. Okay. Don't underestimate the power of the 90-degree angle. Okay. Now let's go. I'm going to ask you to try. Go to page 267. I'm going to leave this up there yet, but you go to page 267. Apply what you've just learned here to that problem. Okay? Basically the same thing. $267. Some of you are figuring out, okay, like this line is cutting it, so this is obviously a 90. So you're going 180 minus 90 minus 17, and you're coming up with 73 here, right? Right? That would be correct. This is the problem. This 73 cannot be paired up with 20. Why not? Because 20 goes from end to end. You don't know what this stretch is here. So that 73 doesn't help you here. You cannot pair it up. Instead, what you should be doing here is, where's my highlighter when I need it? Oh, there it is. Focus on this triangle here. Focus on the big triangle. Don't focus on this cut, that dashed line just yet. The 20, right? If you could figure out this whole angle up here, right? Angle P, then you have a pair, right? So you almost have to, can you do that in your head? Like get rid of that dashed line right now? Just don't worry about it. Think of the big triangle. And so I'm going to go 180 minus 17 minus 36, right? And so that gives me, is that 63? No, sorry. 127, sorry. 127. So this whole thing here is 127 degrees. That is your pair, ladies and gentlemen. That is the pair. You cannot pair up an angle, right, if it doesn't have the side across from it, because some of you were pairing up 73 with the 20 meters. That's not a pair, because the 20 meters belongs to the big triangle. Does that make sense? I hope it does. So go back and try it again. I'll be going over this in a bit. Oh, whoa, time is almost, I'm going over it now. Sorry, I'm looking at my time. It's almost time to go. I got sidetracked. Okay, follow, okay, follow. So I'm gonna go sine, because it's gonna be in tomorrow's AC, something like this. Yeah, that's why I wanna make sure you get this right. Question. It's asking the distance from cat to Pika. So read carefully from here to here. I'm going to call that x. So that means I have to use 36. Listen carefully. I have to use 36. So sine of 36 over x, because they're across each other. Okay, cross multiply and divide. 20 times sine of 36 divided by sine of 127. That is 14.72 meters. If you use the wrong angle, you're going to have them reversed. You found A and B and B and A, right? Like so. Next, I'm using the same one. Make sure you have this, okay? I'm going to use 17 degrees. I'm going to call this Y. The other side, I'm going to call that Y. Notice that I'm not even touching that dashed line right now. I'm like seeing right through it. I'm just working around it. And so it's 20 times sine of 17 over sine of 127. Y is equal to 7.32. Sorry, I'm hurrying, but I want to make sure you have that. And here is the kicker. How wide is the creek? Let's do this before we go. You cut it. Now you're using that dashed line, which I'm going to call W on my diagram. Do I know this side? Yes, I found that to be 14.72. Do I have a pair here? Yes, and I have this as being 17 degrees. Sorry, I'm going to zoom in a little bit. If you're squinting, there you go. This is my pair. So I'm going to go sine of 90 over 14.72. And I'm going to go sine of 17 degrees over W. Cross multiply and divide. And that gives you 4.30. You still have time, 4 minutes. That's my computer saying it. 430, 4 meters, 4.30 meters is the width of the, I will have, like anything we've done so far could be on the AC tomorrow. So just make sure you have a solid study sheet. Maybe have this example on there. I don't care. You are the one that needs to do the work.